Some of the people here will look at this and see a radio. Some will look at it and see a TV. Others, including some of the people here in the SPROCKIT area, look at this and actually see a production studio. Those people are optimists. They're seeing the possibilities of what you can do with mobile devices. We are not optimists. We are pessimists because we've actually seen the data, because we know that the problems with mobile broadband will ultimately disappoint a significant number of the users of those kinds of mobile apps. So, what do we want to do about that? Well, we think we should dramatically improve the performance of mobile apps. And in order to do that, we've spent the last 3 years, raised $11 million, and have a group of very smart engineers who have worked to develop a solution to help improve the performance of mobile apps independent of actually having to deal with the mobile networks themselves. Anybody who's used a rich content experience on a mobile device has seen some of these problems. You're watching a video and it starts to buffer. Statistically, the more you see that, the more likely you as a user are going to abandon that. And that's bad for the mobile app owner. Conversely, if I can get into high definition and keep it into high definition, then the big advantage is the user will watch longer and I'm better able to monetize that application. If I disappoint my user and they abandon, they're statistically much less likely to come back within a week, again, making it harder for you to build audience. So why is this? Well, for one thing, the protocols that are used to deliver these work great across the backbone, in part because we've developed technologies like CDNs that make sure we get reliable delivery across the backbone. It all starts to fall apart at the part that we call the mobile broadband infrastructure, the part where it leaves the CDN and goes out into the world of mobility. Whether that's cellular or Wi-Fi, that's the area where you're going to see the greatest amount of contention in shared media. You've got problems with interference, and bandwidth varies wildly. We actually looked at some statistics from tests that our customers were running, and in a 10-minute session, on average, and this is over a 3-day weekend running a video app, the average bandwidth in the session varied by 239%. That means there were some that varied even higher than that. Those make it very difficult to delight your users and much more likely that you're going to have situations that disappoint them. So what we want to do is start to look and see how can we address the quality of delivery across the mobile broadband infrastructure. Well, we do it by what we call a mobile delivery network. I'm going to spend a moment on this. We'd be certainly happy to go into more detail on this. But essentially, we are helping empower the mobile app owner. The reason for that is it would be very difficult for the mobile app owner to go out and engage all the different carriers and come up with a solution that worked ubiquitously across the globe. There's something like 650 different service providers they would have to deal with. And that's just overwhelming for most mobile app owners. So instead, we say, take some of our technology with our SDK, embed it as part of your app. And then what we're able to do is accelerate from the device out into the Kwicr cloud. It actually terminates on a server inside our cloud. And what we want to do is then do a handoff to the point where the content is served as close to that as is humanly possible, right? And that could be served by a CDN. It could be served on the cloud. It could be served in a data center across the internet. It really doesn't make any difference to us. We're just moving data. And we really bring 3 elements to bear with this. Number one, and which is first and foremost, is acceleration. Right? You would be buying this service because you're concerned that at least some of the time you're not able to deliver the app with the level of reliability and quality that you would otherwise want. But we take that a couple of steps further. Because we're sitting on the device and because we're sitting at the edge of the network, we have got 2 perfect measuring points and we see everything that goes on between that, whether we accelerate it or not. And the truth of the matter is, sometimes the mobile network works just fine. In fact, it probably is a majority of the time that it works adequately for what the mobile app actually needs. So what we look for are those situations, and let's say it accounts for somewhere between 25 to 50% of the time, depending on where you're trying to serve and what kind of app you're trying to serve, where you actually need the acceleration. How do you know that? You can see it in the analytic data that we gather and the tools that we use to figure out what makes sense for a return on investment in your investment in our network. So that brings to the third point, which is policy, or the control element of this. You as the mobile app owner decide how, when, and where you want to accelerate. We've got one customer who's testing right now that wants to launch a streaming audio service in Brazil. That'll be delivered over mobile infrastructure. That's very important to those people who see mobile phones as radios. And so they concluded that they need something to improve the quality there. And we've demonstrated an order of magnitude improvement of about 200%, which now gets them to the level of quality that they want to get to launch into that country. So the trick for them is to say, well, are there other circumstances where networks look like Brazil does most of the time? So that's where that combination of acceleration, analytics, and the control come into bear. If you're already using a CDN, we're very friendly to CDNs. We're trying to minimize the gaps between the CDN and the actual delivery on the mobile device. So as I said, we've done a lot of testing. So I have some real-world results. So we took some of our technology and just ran the Watch ESPN app across our network. They were using Akamai as a CDN. They were using fast TCP, so it was kind of the best technology that Akamai had available. And we still showed, on average, a 30% improvement in throughput. And that's nice. It got them into high def more. It got them into 4K range twice as often. And it reduced the number of stalls by an order of magnitude. So a much more rich experience for the customer. But the average is a little bit misleading. The reality is, on the corner cases where it really mattered, we were accelerating by about 180%. So when the network gets bad, that's when you need to accelerate. If the network's good, leave it alone. Right? So it's fairly simple to try out. You download our SDK from our website, integrate it into your app. It's a relatively simple process. You have a quick call with one of our customer success managers. So we want to know where your content is and make sure that we understand how you're actually delivering the app. And then we turn it on the network. And for the 45-day test drive, we run in an A/B mode, half on, half off. And there you can actually compare what life is like with and without Kwicr.